3 minutes ago, the Pacific Ocean breached a seawall in Pacifica and sent a wall of water surging across Beach Boulevard. King tides reached 2.5 feet above normal, breaking a 28-year record, while storm surge from an atmospheric river added even more height. The combination has triggered the highest-level coastal flood warnings from Mendocino to Monterey. More than 100,000 people live in the path of this water. Roads are flooding, harbors are being battered, and emergency responders are racing to keep up as each tide cycle brings new threats. What happens when the highest astronomical tides in decades collide with a storm-driven ocean surge? Why are scientists warning this could extend through Friday? And if the sensors fail now, who will see the next wave coming? The coast is locked into something it has never faced at this scale before. Highway 1 disappeared beneath seawater just after dawn. Traffic cameras from Caltrans showed vehicles hydroplaning through 6 inches of salt water near Pacifica, their headlights reflecting off a surface that should have been asphalt. By 8 a.m., the California Highway Patrol closed the northbound lanes and began rerouting hundreds of morning commuters. In Crescent City, the harbor entrance breached before sunrise. Fishing boats pinned against docks, their hulls scraping concrete as wave cycles exceeded 8 feet in some areas. Harbor master reports described vessels tossed like debris, mooring lines snapping under pressure that exceeded design tolerances. Dozens of boats sustained damage, and at least 3 sank at their moorings. The Pacifica seawall, already weakened by storms in 2023, showed fresh cracks along its 22-foot face. Water overtopped the structure during the morning high tide, flooding parking lots and forcing evacuations from low-lying neighborhoods. Residents in Mill Valley watched seawater rise along streets that normally stay dry, the bay pushing inland with a force no one had anticipated. This is not theoretical flooding, it is happening now. The National Weather Service upgraded warnings from advisories to full coastal flood warnings at 6 a.m. The decision reflected tide gauge readings at the San Francisco tidal station that hit 2.5 feet above normal, the highest measurement since 1997. Meteorologist Rachel Kennedy described the conditions as a convergence of multiple forces: king tides driven by celestial alignment, storm surge from an atmospheric river, and wind-driven waves all arriving at once. From Mendocino to Monterey, more than 200 miles of California shoreline now sits under the highest tier of flood warnings. The National Oceanic and Atmospheric Administration issued gale warnings restricting all marine movement, with wave heights forecast to reach 14 meters in exposed areas. Buoy 46014, positioned 19 nautical miles north of Point Arena, recorded swells at 13 feet with periods of 15 seconds, long-period waves that carry enormous energy and can amplify when they reach shallow coastal waters. The warning language shifted from possible to expected. Emergency managers in 6 counties, San Francisco, Marin, San Mateo, Santa Cruz, Monterey, and Mendocino, moved to full activation protocols. The rarity of these warnings cannot be overstated. San Francisco Bay has not seen this combination of factors in nearly 3 decades. But the ocean was not finished. In Pacifica, Beach Boulevard transformed into a river. Water poured over the seawall in sheets, carrying sand, driftwood, and debris inland. Businesses along the waterfront scrambled to sandbag entrances, but the water came too fast. By mid-morning, the street sat under 8 inches of seawater, with more rising as the tide peaked. Legazpi reported similar conditions. Entire neighborhoods near the bay shoreline, areas that normally flood only during extreme events, were submerged. Residents waded through knee-deep water to reach higher ground, clutching plastic bags of belongings. Local officials in Naga described a race against time as urban flooding spread beyond the immediate waterfront and into low-lying areas several blocks inland. Crescent City's harbor took the worst hit. The same topography that makes the city uniquely vulnerable to tsunamis, a bowl-shaped continental shelf that traps wave energy, turned storm surge into a battering ram. Boats slammed into docks repeatedly, pilings groaned under stress, and the floating sections of H-Dock lifted off their moorings before jamming in place. Emergency responders cordoned off damaged areas, and Harbor Master Mike Rademacher described the scene as relentless. Evacuation advisories went out for waterfront areas in Marin and San Mateo counties. Families packed into cars and headed inland, many uncertain when they could return. Every hour lost means more people stranded. More than 200 miles of California coastline, from Cape Mendocino in the north to Monterey Bay in the south, faces direct exposure to this event. Harbors, piers, waterfront businesses, and residential neighborhoods all sit within the flood zone. In San Francisco Bay alone, 8 million people live close enough to feel the effects, whether through flooded roads, closed transit lines, or disrupted services.
The threat extends beyond the immediate shoreline. Tidal waterways carry the surge inland, flooding areas that seem safe on elevation maps. In Alviso, sections of Highway 101 flooded during previous king tides, and emergency planners expect similar impacts this time. Inland flood watches now extend across low-lying valleys where rivers meet the bay, creating compound flooding from both ocean surge and rainwater runoff. Gale warnings remain in effect through Sunday evening. Small craft advisories restrict all recreational boating, and commercial fishing operations have halted. Ports from Eureka to Monterey are either closed or operating under severe restrictions, with cargo ships delaying entry until conditions improve. The sheer geographic scale means no single agency can manage the response alone. Coordination between NOAA, the National Weather Service, the California Governor's Office of Emergency Services, and dozens of local emergency operations centers has become the only line of defense. This is a regional crisis unfolding in real time. Every decision, whether to evacuate, when to close roads, which areas need immediate resources, depends on data streaming from sensors scattered along the coast. Ocean buoys measure wave height and period. Tide gauges track water levels minute by minute. Weather stations monitor wind speed and atmospheric pressure. Together, these instruments form the only early warning system capable of detecting what comes next. Buoy 46014 transmits data every hour, reporting swell direction, height, and period to the National Data Buoy Center. Tide gauge 9416841 at Arena Cove sends real-time water level readings to NOAA's Coastal Monitoring Network. These sensors operate continuously, even in conditions that would ground aircraft and disable visual observations. The data arrives faster than human verification allows. Emergency managers refresh dashboards every few minutes, watching for spikes in wave height or sudden changes in tide predictions. When a reading jumps, when a buoy reports 15-foot swells or a tide gauge shows water rising faster than forecast, response teams mobilize immediately. But the system has limits. Sensors can fail, buoys can drift off station, and transmission errors can create data gaps at the worst possible moments. Right now, these instruments are the only eyes on an ocean that refuses to behave predictably. Emergency operations centers across 6 counties shifted to 12-hour rotating shifts. In San Francisco, the Department of Emergency Management activated its coastal desk, staffing it with personnel trained in storm surge response. Marin County's Emergency Operations Center opened at midnight, with teams monitoring live feeds from traffic cameras, tide gauges, and social media reports. Harbor Master offices restricted port entrances. In Crescent City, officials closed the harbor to all traffic until conditions stabilize. Santa Cruz followed suit, securing vessels and evacuating non-essential personnel. Monterey Bay Harbor Master prepared to close if wave heights exceeded safety thresholds, with staff ready to implement closure protocols on 15 minutes' notice. Sandbag stations opened in Pacifica, Mill Valley, and Sausalito. Residents lined up to fill plastic bags, stacking them around doorways and garage entrances. Barricades went up along Beach Boulevard, Highway 1, and sections of the Embarcadero. Evacuation routes were marked with signage, and emergency alerts went out via text message to residents in low-lying zones. Traffic cameras became critical tools. Caltrans monitored live feeds from cameras along Highway 1, Highway 101, and coastal arterial roads, watching for flooding that would require immediate closures. Social media filled with eyewitness reports, photos of flooded streets, videos of waves crashing over seawalls, real-time updates from residents trapped by rising water. Every sensor, every camera, every report fed into a system designed to keep people safe. But the system depended on sensors that could fail at any moment, and the ocean was not finished. No agency has declared the situation contained. Each tide cycle introduces new variables. Wind direction shifts, atmospheric pressure changes, storm surge intensity fluctuates. The next high tide arrives in less than 12 hours, and forecasters cannot predict with certainty whether conditions will improve or worsen. The National Weather Service extended warnings through Sunday afternoon, acknowledging that the window of danger has not closed. Tide tables show another peak at 2:13 a.m. local time, when the combination of king tides and lingering storm surge could push water levels even higher than this morning. Emergency managers describe the sensor network as their only line of defense. If buoys fail, if tide gauges stop transmitting, if data gaps emerge at critical moments, response teams lose the ability to anticipate the next surge. The margin for error shrinks with every hour. Vigilance, not reassurance, defines the response, and the ocean keeps testing every defense. Wes Taylor has fished out of Crescent City for 47 years. He remembers the 1983 storm that tore the harbor apart, when 20-foot waves crashed through the pier and turned fishing boats into wreckage. That storm destroyed docks, sank vessels, and left the harbor inoperable for months. Taylor watched it happen from shore, powerless to save his boat.
"The currents are more dangerous than anything else," he said, standing near his boat Martha as water churned through the harbor. "You can't steer into that." This time, Taylor kept his 3 fishing boats docked. He watched the forecast, monitored the tide predictions, and decided the risk did not warrant evacuation. Others made different choices, fleeing to deeper water hours before the surge arrived. But Taylor stayed, trusting decades of experience and the harbor's upgraded infrastructure to hold. The upgraded harbor, rebuilt after the devastating 2011 tsunami, was supposed to withstand events like this. H-Dock, the floating structure nearest the harbor entrance, was engineered with closely spaced pilings designed to absorb and dissipate wave energy. It functioned as a sacrificial barrier, protecting the interior docks by taking the brunt of the surge. But even sacrificial systems have limits. The swell direction this week matched the 1983 storm almost perfectly, but the conditions today are fundamentally different, driven by forces that did not exist 4 decades ago. The 1983 event was a winter storm, violent and localized. This event combines king tides, the highest astronomical tides of the year, with an atmospheric river delivering additional water volume and storm surge amplified by warmer ocean temperatures. Wave periods today reach 15 seconds, compared to shorter, choppier waves in 1983. Long-period swells carry more energy and penetrate deeper into harbors and bays. The atmospheric river adds moisture and rainfall, saturating soils and overwhelming drainage systems already at capacity. Storm surge, driven by low atmospheric pressure and strong onshore winds, raises baseline water levels before waves even arrive. NOAA reports that Pacific Ocean surface temperatures are running 1 to 2 degrees Celsius above normal. Warmer water means more evaporation, more atmospheric moisture, and more energy available to fuel storms. The atmospheric river currently impacting California carries subtropical moisture, inherently warmer than typical winter systems, according to climate scientist Daniel Swain. The historical playbook, the lessons learned from 1983, from 2011, from every previous storm, did not account for this combination. Engineers designed seawalls and harbors to withstand known threats, but the threat today is evolving faster than infrastructure can adapt. What worked before may not work now. The timing window ahead is narrowing.
High tide peaks at 2:13 a.m. local time, just hours away. Forecasters predict that the strongest wave energy will arrive near this peak, creating a narrow window where flooding could exceed all current records. If atmospheric pressure drops further, if wind direction shifts onshore, if wave heights increase even marginally, the surge could breach defenses that held this morning. A secondary offshore low-pressure system is forecast to develop late Saturday, potentially prolonging dangerous conditions through Friday. The National Weather Service warns that storm surge and elevated wave heights may persist for days, not hours. Each successive tide cycle will test infrastructure already weakened by the initial surge. Emergency planners watch the forecast models with growing concern. The margin between manageable flooding and catastrophic breaches is measured in inches of water height and hours of sustained pressure. A seawall that holds through one tide cycle may fail during the next if cracks propagate, if soil erodes beneath the foundation, if wave energy exceeds design tolerances. Residents in evacuation zones face impossible decisions. Do they return home between tides? Do they wait until Sunday? Do they trust that the worst has passed, or prepare for conditions to worsen? The ocean offers no guarantees. Pacifica's Beach Boulevard seawall has been under documented stress for years. Inspection reports from the Department of Public Works and Highways identify cracks, erosion, and structural fatigue along sections of the 41-year-old wall. Repairs were delayed due to funding shortages, with the city applying for grants to cover the estimated $80 million of a full rebuild. A 2023 winter storm caused $170,000 in damage when waves breached the seawall and flooded Beach Boulevard. The city patched the worst sections, but comprehensive repairs require resources the city does not have. The California Coastal Commission estimates a statewide backlog of over $1 billion in deferred coastal maintenance, seawalls, dikes, drainage systems, and flood control infrastructure, all awaiting funding that may never arrive. Long-period swells worsen the damage. When waves hit with 15-second intervals, the energy penetrates deeper into structures, exploiting existing cracks and weak points. Each wave cycle applies stress to the same sections, propagating fractures and undermining foundations. Engineers describe it as a fatigue failure. Structures that could withstand individual storms eventually succumb to cumulative damage. In Crescent City, the 2011 tsunami destroyed the old harbor and prompted a $50 million rebuild designed to be tsunami-resistant. The new harbor featured 30-inch steel pilings driven 21 to 37 feet into bedrock, compared to 16-inch pilings driven only 10 feet in the previous design. Yet even this upgraded infrastructure showed vulnerabilities during the July 2025 tsunami, when HDOC failed and caused an estimated $1 million in damage to submerged utilities. The pattern is clear. Infrastructure built for yesterday's threats faces tomorrow's conditions. At 9:47 a.m., buoy 46014 stopped transmitting data. For 23 minutes, the National Data Buoy Center lost contact with one of the most critical monitoring stations on the Northern California coast. Emergency responders refreshed dashboards, waiting for the next update, while wave conditions remained unknown. Technicians initiated an emergency remote reboot. The buoy's system cycled, re-established satellite communication, and resumed data transmission at 10:10 a.m. The gap lasted less than half an hour, but during that window, emergency managers operated blind. They could not verify wave heights, could not track swell direction, could not anticipate whether conditions were improving or deteriorating. The incident exposed a fragile reality. The entire early warning system depends on equipment operating in extreme conditions. Buoys are battered by waves, exposed to salt corrosion, and vulnerable to power failures. Maintenance schedules are tight, budgets are limited, and when a sensor fails during peak danger, there is no backup.
The importance of uninterrupted data becomes critical during events like this. A 20-minute gap means 20 minutes without confirmation that the next surge is building offshore. It means emergency managers cannot issue timely warnings, cannot update evacuation orders, cannot allocate resources to the areas that need them most.
The margin for error shrinks with every tide cycle, and the next sensor failure could last longer. 3 outcomes remain possible over the next 48 hours. In the first scenario, conditions ease after Saturday's peak tide. The atmospheric river weakens, storm surge diminishes, and wave heights gradually decline. Evacuated residents return home, harbors reopen, and emergency operations centers scale back to monitoring status. Damage is assessed, repairs begin, and the coast moves toward recovery. In the second scenario, sustained swell prolongs the crisis. Wave energy remains elevated through Sunday, Monday, and into the following week. Evacuations extend, road closures remain in effect, and emergency shelters fill with families unable to return home. Infrastructure continues to degrade under relentless pressure, and the economic toll mounts as businesses stay closed and ports remain restricted. In the third scenario, worst case, the peak surge arrives precisely at high tide. Atmospheric pressure drops further and wind shifts directly onshore. The combination breaches seawalls, inundates neighborhoods, and overwhelms drainage systems. Flooding spreads beyond waterfront areas into inland zones. Hospitals, power substations, and emergency facilities are compromised. The cascade of failures turns a coastal flood into a regional disaster. Emergency planners watch for the signal that tips the balance: a sudden drop in barometric pressure, a shift in wind direction, a spike in wave height reported by offshore buoys. Any one of these could push the event into Scenario 3. The ocean will decide which outcome unfolds. The frequency and intensity of king tide events are increasing. What once occurred as rare emergencies now happen seasonally, driven by rising sea levels and warmer ocean temperatures. NOAA projects that sea levels along the California coast could rise between 1 and 6 feet by the end of the century, turning today's extreme tides into tomorrow's normal conditions. Coastal defenses built for historical conditions face accelerating threats. Seawalls designed to withstand once-per-decade storms now confront events that arrive annually. Drainage systems sized for moderate rainfall struggle with atmospheric rivers that dump 6 to 12 inches in 48 hours. Infrastructure that protected communities for generations is failing under pressures that exceed design parameters. The compounding risk comes from underfunded maintenance. The $1 billion backlog in coastal repairs grows larger each year as new damage outpaces available funding. Cities like Pacifica face impossible choices: invest in uncertain upgrades or risk catastrophic failure during the next storm. Either path requires resources most communities do not have. Seasonal flooding is evolving into a long-term threat. What happens this weekend is not an isolated event, but part of a broader pattern of coastal change. The coastline is being redefined, one tide at a time. And the pace of that change is accelerating. Right now, scientists know the immediate conditions. Tide gauges confirm water levels 2.5 feet above normal. Buoys report 13-foot swells with 15-second periods. Atmospheric river moisture continues to feed storm systems offshore. Wind forecasts predict gusts up to 50 miles per hour through Saturday evening. But what remains unknown is whether the infrastructure will hold, whether the next tide cycle will breach additional seawalls, whether evacuations will expand or contract, whether the sensors will continue transmitting data when they are needed most. The official response is measured, cautious, and grounded in uncertainty. The National Weather Service extends warnings without declaring victory. Emergency managers keep operation centers fully staffed without announcing an end to the crisis. Residents in flood zones remain on alert, uncertain whether to return or stay away. If this combination of king tides, storm surge, and atmospheric moisture becomes the new normal, what does preparedness even mean? If the historical playbook no longer applies, which strategies will keep communities safe? And when the next storm arrives, and it will the coast be ready? The ocean has not finished testing these questions.